Hello everyone and welcome back to another video in this series. In this video we will explore Spring Data JPA for simplified data access, and we will learn how to set up entities, repositories and other components for basic CRUD operations. In addition to that, we will explore JdbcTemplate for programmatic JDBC access and discuss the benefits of using it. Now let's start with Spring Data JPA. The Spring Data JPA is a powerful abstraction on top of JPA that simplifies data access in Spring applications. So JPA stands for Java Persistence API, and basically it's a specification for object relational mapping for accessing and managing data between Java objects. It has Hibernate as an implementation that maps Java objects to relational database tables, so that Java classes are represented as tables in a database, and then various CRUD operations can be performed on it. So Spring Data JPA makes the use of Java Persistence API and Hibernate to make it easy for us to work with applications that needs access to databases and reduces the need for boilerplate code. So it gives us a lot of generated queries that allow us to access databases without having to write a single line of SQL. So in Spring Data JPA, it's all about the persistence layer that offer common CRUD operations by setting entities and repositories. Entities represent the objects stored in the database and are typically annotated with JPA notations like entity, table, ID, etc. Whereas repositories are interfaces that extend JPA repository or its sub-interfaces provided by Spring Data JPA. And Spring Data JPA automatically generates repository implementations at runtime based on the methods defined in these interfaces. Now let's proceed with setting up entities and repositories in our project. First of all, we need to make sure that we have the required dependencies, such as the Spring Data JPA and the PostgreSQL. Now as a next step, let's create a local PostgreSQL database. Before that, make sure you have it installed on your machine, and you can download it from the official website. Once it's installed, we can use the PSQL command line tool. Now let's open it and connect as a super user, which is Postgres by default, created during the installation. And let's create a new database with the name Bookstore. And for this database, we create a user named bookstore_user with an encrypted password. And lastly, we grant all possible permissions, such as creating tables, inserting data, etc. on the Bookstore database to the created user. We can also connect to our database using any database management tool like dbeaver, for example. So we can use it and select Postgres to connect to our database. We provide the host name, which is localhost, as this is created on my local machine. The database name is Bookstore, and we provide the username and password of the user that we have created. We can test the connection, connect, and open it. Now it's still empty, as it has no tables yet. So let's jump to IntelliJ and create our entities. But before creating an entity, let's set up the database configuration in the application.properties file to let Spring Boot connect to it. So here in the application properties, we set the data source URL, username and password of our database. And we specify the JDBC driver class that Spring Boot should use to connect to the database, which is PostgreSQL JDBC driver in our case. And this is provided by the PostgreSQL dependency in the POM file. And after that, we configure JPA settings to interact with the PostgreSQL database using Hibernate as the ORM. This specifies the dialect to use for communicating with the PostgreSQL database, which is Hibernate, and it tells Hibernate how to convert Hibernate queries into SQL queries that are compatible with PostgreSQL. And this controls the behavior of the schema generation process. So it updates the database schema on application startup, creates new tables and columns as needed. And lastly, this property enables logging of the SQL statements generated by Hibernate. Now we are ready to create an entity, and let's name it book. We add the table annotation that specifies the table name in the database, which will be named as book. We mark this class with entity annotation, which indicates that this class is a persistent Java class that maps to a database table, and when the application runs, Hibernate will automatically map this class to a corresponding table in the database. In the book table, we would need a unique ID for each book. We also need to store the title of the book and maybe also the author. And in this table, we need to specify the primary key that would be the ID in our case. So let's add the ID annotation to the top of the ID field. We would also need to define the primary key generation strategy using the generated value annotation. And this inside indicates that the primary key value will be automatically generated by the database, typically an auto-incremented value. And of course, we define the getters and setters for those fields. Okay, now we need the repository interface, so let's create one with the name book repository. This extends the Spring Data JPA's interface, and we define the type of the entity that this repository will manage, which will be our book entity. And long is the type of the entity's primary key that we define in the book class. Now we mark this interface with the repository annotation, indicating that this is a Spring Data repository. However, this is not strictly necessary, as Spring will automatically detect repositories that extend JPA repository, but it's a good practice though. By extending JPA repository, book repository will inherit several powerful features, like CRUD operations for saving entities, retrieving it by its ID, or deleting it. Now let's jump to the service layer, which contains the business logic for entities and typically interacts with the repository to perform CRUD operations. This layer helps to keep the code organized by separating the business logic from the repository and controller layers. So let's create the book service. We need to annotate it as a service, indicating that the class is a service component in the Spring framework. And we need to inject the book repository to this class using the auto-wired annotation. And this will allow the book service to use the repository to interact with the database. Now we can define some business methods, such as save book, to save a new book or update an existing one. Another method, find all books, to retrieve all books from the repository. A method for retrieving a book by its ID. And a method for deleting a book by its ID. Now we have the last step, which is creating a REST controller, so we can perform operations on our book table using HTTP requests. So let's create a book controller. First, we mark it with the REST controller annotation to indicate that this class is a REST controller. And we specify the base URL for all the endpoints in this controller using the request mapping annotation. And of course, we also need to inject the book service here. After that, we can create some endpoint methods, such as for adding a book that handles post requests to save a new book. To retrieve all books, we use get method. And we create the method for retrieving a book by its ID. And last one is for deleting a book by its ID. Now we can run the Spring Boot application, and we can perform a curl post request like this to add a book to the table. Now if we head to our browser to get the books using an HTTP GET request, we can see our book has been added here. We can also use curl delete request to delete that book, and here you have it. Now, if you want to define more complex data retrieval operations beyond the standard CRUD operations, Spring Data JPA allows you to define custom methods in your repository interfaces based on the method name convention. For example, if you want to retrieve books based on the author name, you just need to define this as a name convention for your method in the repository. So here in the book repository, we define the method with the name findByAuthor that should return a list of books based on the author name that is passed as a parameter. Now Spring Data JPA interprets this method name and constructs a query based on the entity's properties. Since the method name follows a specific convention, this allows Spring Data JPA to understand what query needs to be executed. And at the end, Spring Data JPA will automatically create a query like this. And of course, if we want to make this available via HTTP requests, we can bring this to the service layer. So here we define the method in the book service. And lastly, we define it in the API layer. So here is it in our book controller as a GET request with this endpoint. And you can test this method by sending a GET request to this URL endpoint with the author parameter. You can also use native SQL queries with the query annotation by setting the native query attribute to true and defining the query for fetching your desired data. Pagination and sorting are essential for handling large datasets efficiently, and Spring Data JPA provides built-in support for pagination and sorting via the pageable and sort interfaces. Let's check how we can do this, and let's jump to our book controller to make it able to handle pagination and sorting. For example, in the method getAllBooks, we can add pageable interface as a parameter. Here, we would then need to change the type to page instead of list. This will then retrieve books in a page, and we can then define the page number and size to be shown, for example, on the UI. And the same in the book service, we can modify our method findAllBooks. Now we define the findAll method again in the book repository. Now let's run the application. And in our GET request, we pass now the page number as well as the size of the page, indicating the maximum number of elements that it will retrieve, which is the number of books. And we define the sort type. Here, we define it based on the ID and in an ascending order. And here you go, we have retrieved the first page of books, with a page size of 5, sorted by ID in an ascending order. Okay, now let's see another approach of dealing with data access in Spring. It's JdbcTemplate, which is a part of the Spring framework that simplifies the use of JDBC, or Java Database Connectivity. It also removes much of the boilerplate code that is typically required when working with raw JDBC, such as handling connection management, statement creation, and result set processing. In addition to that, JdbcTemplate provides numerous methods for executing SQL queries, updates, and batch operations. However, this approach requires more manual handling of SQL compared to the JPA approach. Here it's the same. We have the controller as well as the service layers. But for data persistence, we need the DAO layer that defines methods for CRUD operations. These methods contain SQL queries and use JdbcTemplate for database interactions, basically JDBC calls. And the JDBC driver then translates those JDBC calls into the database-specific protocol. Now let's see this in an example. First of all, we need to replace one dependency we had for the Spring Boot JPA with the Spring Boot Starter JDBC. We already have the database configuration in our application properties, so we don't need to change anything there. Now instead of the book repository, we will create a book DAO class that will handle CRUD operations by using the JDBC template. So this should also be annotated with repository annotation to indicate that it's a DAO component that interacts with the database. We inject JDBC template to make use of it. And we create the CRUD methods on the book table that we need. So we start with the first method, findAll, to retrieve all books from the database. Here we define the SQL query to retrieve all records from the book table. And the JDBC template query executes the SQL query and maps each row to a book object using beam property row mapper. Similarly, we define the method findById with its SQL query in which we pass the ID as a parameter. The JDBC template query for object executes the query and maps the result to a book object. And the ID parameter is passed to the query. The same for saving a new book. And for updating a book, you can see we can update title or author for a book by looking for a specific ID. And of course, another method for deleting a book by its ID. Now with the JDBC template approach, and since we are working directly with SQL queries, we don't need to define the book class as an entity with annotations like entity. But here, JDBcTemplate operates at a lower level compared to JPA Hibernate and doesn't require the mapping metadata provided by entity annotations. And now we jump to the book service layer, where we already have our business logic. We just need to replace the book repository with the book DAO we created. Okay, maybe we need to change some of methods types here. And the same in the book controller. Now we can check if it works. And here you go. So we have seen both approaches for Spring Data Access Management. Basically, both approaches can coexist within the same application, and each one has its use cases. For example, Spring Data JPA is best for projects where you want to leverage ORM capabilities and work with domain models directly. On the other hand, JdbcTemplate is best for projects where you want fine-grained control over SQL queries. Secondly, Spring Data JPA simplifies development by generating SQL queries automatically, but JdbcTemplate is more suitable for legacy databases or when working with complex, optimized SQL queries. And lastly, Spring Data JPA is useful when you need to handle complex relationships and entity graphs. And JDBC is useful when you need to perform bulk operations or when performance is a critical concern. Alright, that's it for this video. I hope you found it useful and see you in the next one.